People want to know, when are we going back to the moon? When are we going to go to Mars?
Into the moon after it spun into an uncontrolled orbit.
A space colony on the moon.
You ever wonder what it would be like to wake up on the moon, with Earth hanging majestically in the sky above? A cosmic marvel to behold. Picture this: the soundless tranquility, the shimmering lunar dust beneath your feet, and the distant silence of outer space. Now imagine what it would take for humans to make this extraordinary vision a reality. In this captivating exploration, we will journey through the fascinating, uncharted realms of space, unveiling the secrets and possibilities that lie within our celestial neighbor. From the mesmerizing concept of a permanent lunar colony to the technology that could make it a reality, we'll uncover the mind-bending ideas and innovations that could soon transform the moon into a bustling hub of human activity. Why colonize the moon, you ask? The answer may surprise you, as the idea of colonizing the moon holds a trove of concealed benefits that beckon us into the depths of space. It can serve as a stepping stone for our journey to the stars, offering a gateway to deeper space exploration. It might also hold the key to our long-term survival as a species, protecting us from unforeseen catastrophes on Earth. Prepare yourself to explore the fascinating frontier of lunar colonization, where the limitations of human ability and the secrets of the cosmos intersect in a breathtaking show. Recently, NASA is about to unveil an awe-inspiring vision for our lunar future. As we inch closer to the ambitious Artemis mission that aims to put boots back on the moon's surface by 2024, the question arises: what happens after that historic touchdown? In the words of NASA Administrator Jim Bridenstine, after 20 years of continuously living in low Earth orbit, we're now ready for the next great challenge of space exploration: the development of a sustained presence on and around the moon. Introducing the star of this lunar saga, Artemis Base Camp, a captivating concept that promises to be a permanent cornerstone for lunar exploration. But that's just the tip of the crater. NASA's lunar orbiter is diligently preparing Artemis astronauts to navigate, map, and identify lunar landmarks while marking out areas of interest for future lunar landings. But what does a moon colony need to thrive? We're talking infrastructure for power, waste disposal, communication, radiation shielding, and even a landing pad. Imagine testing groundbreaking techniques for dealing with lunar dust, transforming lunar resources like water, and developing cutting-edge power and construction technologies. In an exciting twist, NASA, alongside the Canadian Space Agency, recently revealed the intrepid astronauts for the Artemis II mission. Could all this lunar activity be a cosmic step towards colonization? Well, let us dive into the benefits of building a permanent moon base. A lunar base, with its lesser gravity and abundant resources, emerges as the ultimate launchpad for interplanetary adventures. The moon's gentle tug requires less energy to break free, slashing costs and technical hurdles for interstellar voyages. This lunar stronghold isn't just a base. It's a catapult propelling us towards the enigmatic realms of Mars and beyond, ushering in an exciting era of economical and eco-friendly space exploration. Lunar bases are unparalleled hubs of scientific discovery, providing an extraordinary setting for deep dives into fields like astronomy and geology. As our lunar neighbors hold secrets of Earth's past, investigating lunar rocks and craters can yield profound insights into our planet's history. Beyond our blue world, these bases act as cosmic observatories, enabling the study of distant galaxies and celestial phenomena, thus expanding our understanding of the vast enigmatic cosmos. Not only this, the moon, rather than Mars, is just a few days' journey from Earth, making it an accessible target for colonization. This proximity allows for regular missions, resupply, and communication, reducing the challenges of deep space travel. The establishment of lunar bases not only expands humanity's celestial footprint, but also acts as a catalyst for nascent industries like lunar mining and space tourism. These ventures promise economic growth and revenue streams for the nations participating in lunar exploration. Now, what about the hidden elements that our moon contains, which may help and improve our colonization process? Large amounts of ice to generate drinking water. Rocks on the moon have oxygen contained in them. Low-cost energy may also become a reality since the moon has a large amount of helium-3. There are many natural resources on the moon that Earth's inhabitants can extract, such as hydrogen, oxygen, silicon, iron, magnesium, calcium, aluminum, manganese, titanium, etc. The soil of the moon is very easy to mine and can be useful in many ways, including protection from radiation, and it can be used also as a construction material that can be used to protect future human houses from falling meteorites. As of economic cost, the US could lead a return of humans to the surface of the moon within a period of 5 to 7 years, from authority to proceed at an estimated total cost of about $10 billion, plus or minus 30%, conclude NASA's Alexandra Hall and Next Gen Space's Charles Miller in one of the papers. McKay emphasized to Popular Science that a key insight is how innovative technologies, even those unrelated to space, such as self-driving vehicles and waste recycling toilets, are significantly reducing the cost of establishing a lunar base, making it increasingly attainable. In more recent years, multiple space agencies have drafted proposals for building colonies on the moon. In 2006, Japan announced plans for a moon base by 2030. Russia made a similar proposal in 2007, which would be built between 2027 and 2032. In a world bound by borders, the moon represents a shared frontier where nations can unite, pooling resources, expertise, and ambition to achieve what no single country can do alone. Collaborative efforts distribute the costs and risks, accelerate technological advancements, and foster global peace through shared goals. In the infinite expanse of space, the moon is our collective canvas, and international cooperation is the brush that paints the future of lunar colonization, promising shared benefits for all of humanity. It's an inspiring vision where borders dissolve and the quest for knowledge, sustainability, and human resilience takes center stage on the lunar surface. As the saying goes, the three most important considerations in real estate are location, location, and location. For this reason, multiple proposals have been made over the years to construct lunar habitats in locations that would allow for natural protection and/or containment. Any attempt to colonize the moon will need to leverage technologies like additive manufacturing, aka 3D printing, robot workers, and telepresence. The base, or bases, will also need to be manufactured and supplies as much as possible using local resources, a method known as in situ resource utilization, ISRU. NASA and the ESA have been exploring the concept for many years, and both have produced their own methods. Their proposed method for building this base consists of placing inflatable frameworks on the surface, which would then be covered with a form of concrete made from lunar regolith, magnesium oxide, and a binding salt. NASA has proposed a similar method which calls for robotic workers using sintered regolith to 3D print bases. This consists of melting regolith by bombarding it with microwaves, then printing it out as a molten ceramic. Other ideas involve building habitats into the ground and having an upper level that provides access to the surface and allows natural light in. There's even the proposal for building lunar settlements inside stable lava tubes, which would not only provide protection against the vacuum of space and impacts, but could be pressurized with greater ease. Crafting a lunar colony is an audacious commitment, demanding a treasure trove of time, resources, and boundless energy. While reusable rockets and cost-cutting innovations ease the financial burden, the journey to the moon remains a substantial investment. That's just the beginning. Life on the moon comes with a wild mix of challenges. Imagine experiencing temperature extremes that swing from a scorching 117 degrees Celsius 242 degrees Fahrenheit on the sun-soaked side to teeth-chattering minus 43 degrees Celsius, minus 46 degrees Fahrenheit in the lunar shadows. Meteoroids and micrometeoroids continuously rain down, leaving their mark on the lunar surface. Adding to the lunar drama, there's the moon's wispy, almost vacuum-like atmosphere. This unique setting accentuates the radical temperature fluctuations and makes the lunar surface a battleground for meteoroid impacts. And then there's the issue of radiation. With no protective atmosphere or magnetosphere, lunar colonists will be subjected to higher doses of solar radiation, particularly during solar events, as well as cosmic rays. It's a harsh reality that calls for groundbreaking technologies to keep our lunar pioneers safe in this uncharted frontier. The journey to conquer the moon comes with cosmic challenges, but it's an adventure fueled by human resilience and innovation. Our strides in technology, sustainable living, and international cooperation have already propelled us closer to the lunar horizon. So, can we colonize the moon? The resounding answer is yes. Not just because we have the tools, but because we have the enduring human spirit that thrives on exploring the unknown, pushing boundaries, and reaching for the stars. The future of lunar colonization is in our hands, and it's looking brighter than ever before. Thank you for joining us on this inspiring adventure. Join us on this cosmic odyssey by tapping on the red planet named subscribe mentioned below so you never miss updates on more intriguing upcoming adventures.